Okay, so my voice is audible.
Yes, sir.
Okay, so we were discussing the concept of PDA, Pushed on Automata, and in that context, we have done one example. Okay, and let us see. You know, okay, so let us cover a few more things about PDA, and then we'll move to the next topic. So this transition function must be clear to you. Okay, so what we are doing is that we are considering. So let me write one q naught comma. Okay, let's suppose we're taking an input alphabet A and the top of the stack is Z naught. Okay, so this was the setup, okay, which we were considering in order to start. Okay, so based on this particular configuration, what we are doing, we are making transitions. Okay, so this q naught is nothing but this q. This A can be, this A is basically an input alphabet. Okay, so here what we are saying is that we can consider an empty also here, okay, along with the input alphabet. And this inverted L is representing the stack symbol. Right now, the top of the stack is Z naught. Okay, considering this configuration, we can move, we can make transition to the subsets of this. Okay, Q cross inverted elastic. Okay, so here it we might push into the stack. Let's suppose remaining the same state. Okay, so this might be the case. This. Okay, so this Q is your this one of the state, and this inverted L asterisk is your push down symbol. That was the case. I think I've given you one question to attempt. Have you people tried? Equal number of A's and B's I've given you, where A and B can occur anywhere. So if anybody has done it, then they can post the group, okay, so that we can discuss it. Post the answers in the group. Let me see how you are doing. Good morning, sir. मिल गया सर. Is anybody is able to do that problem? Hello, hello.
Yes, sir.
So post the solution in the groups. Let us discuss that. Yeah, the concept is clear to everyone. The PDA concept, everybody is getting the concept how we are designing the transition functions. Okay, so I am assuming that you people have not done the problem. That's why I'm not getting any inputs from you. Okay, so let's discuss. Okay, so let us discuss the definition for final state acceptance as well as null state acceptance. Okay, so in this case, we have, I think, discussed the final state acceptance, and likewise, there is definition for null state acceptance as well. Okay, so by these two means, we can accept the string. Okay, so let us see that if we are able to get it, this one. Okay, so this definition we have seen, I think. So this we have to remember this one. This is your final state acceptance. Okay. Likewise, there is one more definition for this. That is this one. This is null state acceptance. Okay. These two are the ways by which we can accept the string. This A is your automata, and which constitutes of this tuple Q summation inverted L delta Q naught Z naught F VAPDA. The set NA, okay, accepted by null store is defined by this particular set builder notation. What is W? W is combination of input alphabet such that considering from this initial configuration, that is Q naught comma W comma Z naught. Okay, we after making zero or more transition, we we have to erase the entire stack. Okay, so that's how we are saying that that is null store acceptance. Okay, so if we are able to make empty, we are able to empty the store, then for some state q, then we can say that it is accepted by null store. Okay, so yeah, so this will be a slight variation, nothing else. All things will remain same, but the only thing we had to add at the end is that we have to remove the uh, top of the stack as well. Okay, so we have to make it empty. Okay, so that is the this is another definition. And let me show you another variant of this PDA, that is uh, NPDA. Okay, so let me show you one example. I think, let us see. This is Rust. So I want to give you a concrete example so that you can follow that particular example. Let me see. Martian. It is in the supplementary example. Yeah. So yeah, this one, this example, this question. So construct a PDA accepting all palindromes over A comma B. Okay, so for this, basically you cannot design a deterministic PDA. Okay, so for this you will design an NPDA basically. NPDA. Okay. NPDA means non-deterministic push down automata. Okay, and basically as you can see over here, these transitions. So considering an initial configuration, you can make transitions to any one of these two states. Okay, so that we are allowing over here. That's why it is NPDA. Okay, so likewise, if you are in this configuration, you can make one of these transitions. Okay, so you can make these two transition and you will consider the string. Okay, so likewise, the, all these are examples. Okay. So this is the language. So is it clear to everyone? Okay. So okay, so this was the question which I have given to you previously. Okay. Hello. Hello.
Yes, sir.
So post the solution in the group so that I can see. Hello, nobody's posting anything. Are you people not getting the concept? At least post. Let me see whether you are doing it correctly or not. Okay, let me see. Okay, so let us move to a new concept. Maybe wherever somebody will post, then we'll discuss. Otherwise, okay, it will be not clear that whether you people are able to design the PDA or not. Okay, so all of you try to design the PDA and at least post so that we can see how and where you're doing the mistakes.
Sir,
Huh?
I have
Batao?
posted. I have
Posted?
posted WhatsApp essay. It's it right or wrong?
Posted, but I have not received.
WhatsApp.
Okay, yeah. Yeah, wait. So, okay. So let us review this. Let us review. So here, this was basically for equal number of A's and B's. So this is what we have. But here, try to write the transition function. Okay. So from this, it is not clear that what you're trying to do. That's why it is better if you can write the transition functions. So let us try what C has tried to do over here. Z node is on the top of the stack. Okay, so this is nowhere close to the solution. Okay, because here we cannot interpret that what you are trying to do. Yes, that is not obvious because neither you have stated from which state we are going to start. Okay, so this is not at all. We cannot consider this. Okay, anybody else? So who has posted this? Nandita, है ना? So
Yes,
Nandita,
yes.
yeah, this is not interpretable. Anybody else? Hello. So Nandita, can you can try to explain what you are what is the interpretation of this diagram?
Sir, initially I have taken stack is empty.
Okay.
Then with Z node I have at top of the stack I pushed Z node and then A and then one more A. I mean languages we are taking example as the one AA and BB. I mean
So
same length of
these are the
same length.
strings which you are considering. है ना?
Ah yes sir. Ah yes sir.
Yes.
Strings.
So the first thing is
Then
that okay, so let me make it clear. The first thing is that we don't have to push Z naught. Z naught is our initial setup. Okay. So you will be in the state Q naught, and let's suppose you are considering an A, and the top of the stack will be Z naught by default. You don't have to push it.
ah
Okay.
yes sir. Sorry. Sorry.
This is the setup. in this case, what do you want to do? Tell me
Then we have to.
whether you want to remain in the same state, pushing A into the stack.
Yes, sir.
Say something. What is your idea? What is strategy that you're willing to apply?
Just
We should.
getting to initial means what we are with.
So here, first
Mm,
thing is that you should remember. You have to remember. Okay,
yes, sir.
this A. So for that purpose, you have to push A into the stack. So that you have to write like this. Okay. Likewise, other transition function you have to design. Let's suppose in Q naught there will be B which can encounter at the beginning. So what you have to do in that case, you want to push into the stack, and you want to push into the stack or not?
Yes, sir.
Yes. So we'll push into the stack, remaining in the same state. Okay. Okay. After that, what you should do? What are the possible options which you can get? That you have to check. Okay. So here we are suggesting that either A arrives or B arrives. We'll push into the stack. Okay. And the other possibilities, let us write it. So Q naught in the state Q naught, we can read an A and the top of the stack is A. Okay, this is possible. So what we need to do in this case, what we should do? We should push into the stack or not?
No, sir.
No. So okay, so let us take few cases. Okay, so here A B A B. Okay, so this is the string.
Yes, sir.
So if we get an A, then we'll push. Okay,
Yes, sir.
and for B we'll pop an A.
Yes, sir.
Okay, that same concept will apply again and again. We'll push an A for
Push and
B,
pop. Yes.
push and pop. So that has to be done only for
Then he. Yes,
uh,
sir.
only for when we are observing A B and the top of the stack is A. You getting?
Yes, sir.
Yeah. So here
Then we
in this
have to
case,
push.
when it is A, then we will push. Good.
Yes, push. Yes, sir.
Yes. So here we will do a push operation. That will be A. Okay.
Then we
Likewise,
identify.
for
Yes, sir.
BB also we have to do it. So if we are in the state Q naught and the string we are reading is B and top of the stack is B, let's suppose. So in this case also we'll do a push operation. Okay. So this will be B.
Yes, sir.
So there are few more things which are uh, oh, here I cannot rub it. So let me write. So Q naught. So it can happen that we're reading a B and the top of the stack is A. Okay, so now what we need to do? We should
Pop.
pop. Good.
Pop.
So we'll remain the same state and we'll do a pop operation. That will represent by this empty symbol. Okay, this empty symbol is representing that pop operation. Okay, so this
Yes,
is the
sir.
empty. Likewise, for Q naught state, it can happen that you're reading an A, our stack is B. So in that case, what we should
Push.
do? We should
Push.
push or pop because this is different, na? This is different.
D-
We should do a
Push.
we should do a
Push,
pop.
sir.
Okay.
Yes, sir. I got it, sir.
Got it, na? So for
Push.
B, we are popping an A, and for an A, we have to pop a B.
Yes, sir.
Got it?
Sir, understood.
Yes. So, and one more thing is left, that when the string is, we have completed it reading, then we'll in the state q naught, comma, we'll read an empty from the input tape, and the top of the stack should be z naught definitely. Okay.
Yes.
Then in this case, we'll move to a final state. To f empty z naught. Okay. Now you can pick any string. Let's suppose b a b. Let's suppose. Okay. So in this case, what will get man triggered? This will be triggered. This one will triggered first. I don't know whether the
Yes, sir.
color you're able to see. This one will triggered first because we are here. We are reading a b from the input tape. So this is the configuration. So we'll push into the stack. B will push into the stack, and then uh, having B into the stack, reading an A, what will be triggered? Just see what is matching.
We pop B and then push A.
Yeah, this one will match. Okay,
Yes.
this is B on the top of the stack. We're reading an A, so we'll do a pop operation. Got it?
Yes, sir.
Okay. So for this A, this we will be pop on the stack, and then again we are reading an A. Okay, top of the stack is Z naught. So this will be triggered. This one we are reading an A. Top of the stack is Z naught. So we'll push A into the stack. Okay, so A will be stored in the stack, and then for the next, we're reading a B, top of the stack is A, so this will be triggered. So again, we'll do a pop operation. For B, we'll pop an A. Okay,
Yes.
and then after here we'll have empty that will read. Okay, so this transition will triggered where we are reading an empty and the top of the stack is Z naught, Z naught. Okay, then we'll move to the final state. Okay, so you have to make sure that when you have to do a push operation and when we have to do a pop operation. Okay, and whether we need to change the state or not, that also is important. Here we have not at all changed the state because at any instant of time we can get an A or B that we want to push. Okay, so in this particular case we can remain in the same state. Okay, so it will depend upon problem whether you should change the state or not. So is this is clear to everyone? This is making sense?
Yes, sir.
Okay. So you have to write the transition function like this. Okay. Then only we can interpret it that what you are trying to do. Otherwise, interpretation will be not easy for me. Okay.
Okay,
So
sir.
yeah. So here you can write, for example, PDA something like this, PDA, and you should state the tuples. Okay. What is Q? What is summation? Uh, this delta is you are defined over here. Delta. Okay. Stack store symbol Z naught. Okay, I might have missed, I think, one of the tuples. 3, 4, 5 we are having. Maybe. Let us see. So, okay, so that you can recall. 1, 2, 3, 4, 5, 3 to 5. Q naught, no. This, yes, Q naught definitely it will be initial state. Z naught is top of the stack. I think maybe it's okay. You can cross check whether I'm missing some tuple. Okay, so all these you have to define. What Q here only state is Q naught. Okay, summation here it is very clear that is A comma B whole asterisk. है ना? Delta this we have defined. All these are deltas. Inverted L here the push down store symbol is Z naught and A comma B. Okay, so one thing which you should remember. Let me show you that. So Z naught basically is your push down symbol. Okay, so there is as let me see. So this see here, this Q is there. I think this Q not we have not, and this F we have not. Okay. So this is the 3, 3, 6, 7 tuples will be required in order to define a PDA. Okay. So in this Z naught is basically one of the push down stack store symbol. Okay, this Z naught because it will be remain in the stack only. Okay. So yeah, so there will be difference between input symbol and push down symbol. Okay, so not every, so it can happen. So definitely whatever you're reading from the input tape, okay, one might push into the stack or pop into the stack based on the problem. It is not necessary that these two will be same, these two. Okay, so that you have to remember. So so here can you can try, you people can try this question. WCW transpose such that W belongs to A comma B holistic. Is this question is clear to everyone? So what is W? W is can be combination of A comma B holistic. Okay, but here this structure we are trying to find out. Okay, what is the structure? So let's take B as our W. Okay, then we'll get a flag that is C. Okay, C is the flag indicating that after that we'll reverse it. So we should get A, B, A. Okay, so that is your W, C, W transpose. Okay, so for this, what you should okay, so let us take, this is our string A, B, B. So so tell me what you want to do with this A. Whether you want to push into the stack or not. Hello. What you should do? You should push into the stack or not for this A.
Yes, sir.
Okay, so let us write it A Z naught. So whether we should change the state or we should remain in the same state. Hmm?
Remain the same state, sir.
Okay. So we'll remain in the same state. And what we should do? We should push into the stack.
Yes, sir. Push into the stack.
Yes. We'll push into the stack. Okay. So what is the strategy over here? The strategy is we'll push everything. है So entire this thing before C, all this we should push into the stack, this part. Okay. Why we'll pushing it? Because we have to match with the string on the right hand side of the C. Okay, so that we can match. Then only we can confirm that this is the reverse. Okay, this is the reverse. Otherwise, we cannot do it. So this entire thing we need to push into the stack. Push. And this entire thing for a B will pop an B. For B again will pop a B, and for an A will pop an A. In that, and likewise we can match. Okay. If that is the case, then we can reach to Z naught while reading an empty while we have completed the uh, processing of the string. Okay. So considering that, now you can try to design. Okay. So where to change the state, that also you need to remember. Okay. And what to do with this C, whether we should push into the stack or not for C. For C, what should we do?
Can you skip it, sir?
Yes, yes, we can skip it. Skip it means basically means here neither will do a push operation nor will do a pop operation.
Okay.
Okay, so what, how you can write? You can write like this. So let us, so Q naught C and the top of the stack, either it can be a B or it can be an A also. Okay, so it will depend. So we need to write all the possible configuration for that. Okay, so in this case, uh, okay, in this case, so whether we should change the state or we should remain the same state. Hello,
Change the state.
we should change the state definitely. Okay, so here let me make it Q1. Okay, so this is suggesting that we are not doing anything, we are simply ignoring C. Okay, because the top of the stack is not changed, that what it is suggesting. Okay, so previously it was B and now also it is B. Okay, so you have to write all the possible uh, configuration. Okay, so here you should write like this. Okay, so this is suggesting that we are ignoring this C. The top of the stack is not changed. Okay, now you can try to complete the entire set of transitions. है ना? Try and post in the group, because I have written only few. Rest of the other you have to write for because here you have to consider B can appear in the beginning also. So for that you have to consider an A can come after reading an a B can come after reading a B. All those possible combination you have to checklist. Then only we can have a complete set of transitions. So write that transition entire set and post into the group. Let me see. So if you are having facing some problem understanding this, then what you can do, you can take a stack and you can take an input tape like this. Okay, and then you can place your input over here. Let's suppose A, B, C, B, A. Okay, and like this you can design and you can keep in your mind that what is happening. So initially it is Z0 in the top of the stack. So considering this, we will need to do a push, move step by step. You can cross check what you're doing. Okay, so this will be lengthy. Once you practice this way of analyzing the things, then it will be very easy. Okay, but this is the thing which is happening. Okay, so try to post a solution. Let me see. Okay, anyone has any questions regarding PDA? If you're facing problem, let me know.